Bismillahirrahmanirrahim. Today I want to talk about something interesting. Previously we talked about finding midpoints between two given points. So if I've given a point here, point A and point B, and if I was to ask you to find the midpoint, that's easy enough. You take the average of the x's and average of the y's and you get the midpoint. So just as a review, the midpoint formula, MIDP, midpoint formula is simply the average of the x's, x1 plus x2 and divided by 2, and y1 plus y2 divided by 2, and that will give you the midpoint between any 2 points given on a Cartesian plane. But today I want to do something more interesting. Let's say I wanted to find a point, and that's not in the middle, but maybe 1/3 the distance from A to B. So I want to find a point, point C. Point C is 1/3 from A to B. In other words, if you had the whole distance here, if you take 1/3 of the whole distance, okay, if I were to take away only the 1/3, let's say I take away, this part of it, now I only have 1/3 of it, then that would be point C. So I want to find point C, which is, it's going to be over here. I kind of see that, but I want to know the exact ordered pair for C that's only 1/3 the distance from A to B. Now, how do I go about doing that without, kind of guesstimating it by looking at the picture? I don't want to guess. I want to know exactly, precisely 1/3 the distance from A to B. So let me put it this way. From A to B, whatever the distance is, I want to know from here to here, that's 1/3, okay? 1/3 the whole distance from A to B. It's not the midpoint, it's like the 1/3 point, okay? So all I know is that from A to C, that distance is 1/3 of the whole distance. So this is 1/3. And I want to know what the ordered pair is. Okay. So to give you a practical example of this, and I'm thinking this has never happened to you before because you probably don't drive. Now pretend I'll give you a story here, okay? Pretend A and B are like my home. A is like my home, and B is like my friend's home, and I want to go visit my friend, okay? And I have two problems in this particular scenario. The first scenario is that there is construction in this main road over here that goes from my house to my friend's house. So I can't go this way, okay? Forget that. It's construction. So the second problem I have is that my car's busted. It's got like a slow flat tire. One of the wheels is just keep losing air, and I periodically have to stop at a gas station and I have to fill up the car, this tire with air. So okay, so that's a problem because I know that the only gas station available is right here at point C, which is 1/3 the distance. So point C is particularly important to me also because there's a gas station there we can stop by and fill up the air in my tire, because if I don't, I might get stuck in the middle of the road. Okay, so now, so I can't go from here to here because this road is in the construction. So I have this idea. I'm going to go this way and go this way. Right? And then because I have to go to the gas station, and then I'm going to go this way over here and then go like that way because I'm confident I could manage that with my tire, but I can't do the whole thing. So what I'm trying to say here, you can think about going from A to B in different ways. You can divide the journey into different parts, okay? So every journey like this in Cartesian plane can be divided into 2 parts, okay? It can be divided into its part that's in the x direction, and it can be divided into its part that's in the y direction here. So every journey can be divided into 2 component journeys. It's direction in the x direction journey, okay, and in the y direction journey, okay. So in other words, from here to here, this is like the change in x direction journey, the difference that's in x direction. From here to here is the change in y direction, the difference in the y direction. So every journey can be divided into this direction. I could go straight, or I could go in this direction and this direction. So you can think about a journey going in a straight way or going in divide the journey or into 2 parts. The part that is in the horizontal direction and part of the journey that's in the vertical direction. Okay, that's fair enough. So, and then the thing is, if C is 1/3 the distance from it, that's easy to find, because if I find the whole journey in the x direction, I can take this distance and cut that distance into 3 parts, and I take 1/3 of this, 1/3 of this, and if I take the y distance, And if I divide that into 3 parts, 1/3 here, 1/3 here, and 1/3 here, okay, then that will get me to C. Okay, in other words, if I take going from here to 1/3 to here is the same as going 1/3 to here and 1/3 in the y direction. More than that, and that applies to anything. If I wanted to go 5/6 of the whole distance, I go 5/6 in this direction from here to here, and 5/6 in this direction, 5/6 of this. So any distance that's on the segment AB, any distance from here AB, if it's 1/3 here, it's going to be 1/3 in this direction, 1/3 in this direction, in these two segments here. Okay. So to find the ordered pair C, what I have to do is first find change in x from this whole distance over here. Okay, and then I have to find the change in y, that's this whole distance over here. And that's pretty easy to do because the change in x, okay, is basically the absolute value of the two x values. So I take x1 minus x2, and I take the absolute value of that, and that'll give me the change in distance, because the absolute value is distance between any 2 points. And then in the same way, the change in y is pretty easy to find, because that's simply the absolute value distance in the y direction. So that's just simply y1 minus y2. Now, it doesn't matter if it's x1, x2, y1, y2, because they will amount to the same thing, y1 minus y2. Okay, in other words, I could have rewritten this as x2 minus x1, and that would be the same thing, and this would be y2 minus y1, and that would be the same thing. Now, that's kind of complicated, sounding kind of cool looking actually, if you ask me. But this change in x simply means, okay, what's the difference between the ordered pair from here to here on the x-axis? So this is from -3 to 3. That's this distance from here, okay? That's what that means. That's the change in the x, the change in the x direction. And the change in y direction simply means what's the difference in the ordered pair from the y direction from here and to the y value over here. That's this direction over here. Okay, so this distance can be characterized in its x direction and in its y direction. So to find C, let me find C over here. To find point C, the first thing we need to do is find the let's call C the ordered pair xy. So to find the ordered pair x, let's find the x value for C. First, we have to find the change in x direction, okay, from here to here, and that's easy enough. And I'll go from this 3 over here and subtract that from, and then subtract that 3 from the other 3 minus 3. So distance always you subtract. 3 minus 3, that's plus, and that's plus 6, and that is going to be 6. Now, I subtracted 3 minus 3. I could have also done this over here. I could have done -3 and then -3. The other way, I could have flipped the order from the x coordinates, x2 versus x1, -3, -3, and this is absolute value of -6, and that's 6. So you can see it doesn't matter which point is x1, which point is x2. It works out in the end just fine, right? So anyway, so I don't want to duplicate my work. So the change in x direction, that this ends up being 6. In other words, there are 6 units or 6 boxes. That's 1, 2, 3, 4, 5, 6 boxes from here to here. Got that. Now, to find the x value over here, I only need to take 1/3 of that distance, 1/3 of the change in x. Okay, 1/3 of the distance, because I'm only going to 1/3 because if I want to get to that gas station, right? If I said, okay, so I take 1/3 of the x distance, 1/3, that's 1/3 times 6, as this simplifies, that's 2. Okay, so in other words, 1/3 of this whole distance, 1/3 of the whole distance is just 2 units here. From here to here, it's 2 units. Got it. All right, that's easy enough. So to find the x value, I just go from here and go over here, and they'll give me the x value of the ordered pair C. Of the point C. So I take -3 and then add this distance over here plus 2, and that's -1. So the x value is -1. Now I have to find the y value of C. To find the y value of C, I do the same thing. First I find change in y. Okay, so I take 4 minus 1. 4 minus 1, that's y2 minus y1 or y1 minus y2. Either way, it's going to be the same, doesn't matter. So that's 4 minus this 1. So the change in y direction is going to be absolute value of 3, which is 3. So this is going to be 3. Now, I just need to take 1/3 of that, okay, because I'm not going the whole thing, I'm just going 1/3 the distance. So I take 1/3 of that distance, 3, and I get 1. Now, and then what I do is I take this y value and I take 1 unit away from here and add 1 unit this way. I get the y value too. There it is. So I take y value is going to be 1, which is the y coordinate of point A, and I add 1 to it and I get 2, and I get y value to be 2. So the ordered pair C is -1 and 2. Okay. So how did I do this? I found the whole distance over here and I took 1/3 of it, and I found the whole distance over here and I took 1/3 of it, whatever this distance came up to be, and I added that to the each respective x and y values. -3 plus 2 gave me 1, and 1 plus 1 gave me 2, and that's how I found the ordered pair C. Alright, allow me to give you one more example, inshallah. Okay, here's your question. Same problem. Same coordinates, but here we're trying to find point K. K is 5/6 the distance from A to B. Okay, that means it's like if you divide this whole thing into 6 parts, it's 5 parts away. Okay, all right, so that's going to be somewhere over here. Let's just label that point K. Okay, now again, to find this, I have to find this whole distance from here to here. Okay, from here, the whole distance, that's going to be the change in x. Okay, so I find the whole distance over change in x over here, and then I find this whole distance over here, that's going to be the change in y. Okay, so let me put it this here. This is the change in x, the whole distance, and this is going to be the change in y. This whole distance, I can divide my journey into this, and whatever that distance is, I don't have to take the whole distance over there. Rather, I take only 5/6 of that distance, and I take 5/6 of this distance over here. Okay, so let me draw that part of it on this particular graph. So I take 5/6 of the whole distance in the x direction, and then I take 5/6 of the whole direct change in the y direction, and then I'll get over there. Okay, so let's do it again. So the x, to find the x coordinate of K, let's call this xy. And here we go. So first I find the change in x. That's going to be, again, the same thing. I've done this already. I know that. So it's going to be 1 minus 4. Oh, sorry, I did that wrong. It's going to be -3 minus 3. Okay, it's going to be -3 minus 3. That's absolute value -6, and that is 6. And here I take 5/6 of that. So the 5/6 of change in x, that's 5/6 of 6. That's going to be, it goes in there one time, that's going to be 5. And then I simply add 5 to the x value of here. So x is going to be equal to -3 plus 5, and that's going to be 2. Ta-da! Easy enough. To find the y value, I do first find change in y, which is going to be 1 minus 4, and that's going to be -3, and that is 3. Now I take 5/6 of this change in y, so that's going to be 5/6 of 3, and that 3 goes in there 2 times. That's going to be 5/2, which is 2.5. Okay, so the y value is going to be this y value, that's 1, plus 2.5, or 3.5. Ta-da! So K is in fact 2 and 3.5. There we go. That's pretty good. So K is going to be 2, and that's this point over here. Let me draw it close to over here. 2 and 3.5, and we're done. Okay, so again, the idea was to find distance from in the x direction and distance in the y direction. Take the fraction that you want and add that fraction to the ordered pair where you're starting from, where you know the distance is. Now, I'd like to share with you slight variation of the same problem, which some students find somewhat challenging, but it's not difficult if you understand the concept, and that is the concept of ratios. Okay, just a few minutes ago, I told you that this point C, the example that we gave, was 1/3 the distance from A to B. That is, this was 1/3 the distance from A to B. Another way of saying the same thing is that the length of AC, the ratio of AC to CB, that is from this compared to this, okay, the ratio of C to CB is 1 to 2. Now that sounds kind of funky if you put it like that, and that is the ratio of this segment to this segment is 1 to 2. You might have thought I would say the ratio is 1 to 3, but that's not true. See, you have to understand what this notation means, and you have to understand what this notation means. This notation is saying, okay, AC is 1/3 of AB. That's what that means. This means AC is 1/3 of the whole segment. Okay, now, so if you write this, C is 1/3 the distance. If you say 1/3, so this means that AC, okay, AC is 1/3 of the whole thing. Okay, AC is 1/3 of AB. Okay, that's what that means. Now, what this is different. See, here we're comparing the small segment to the whole thing. Over here, we're taking AC, comparing this small segment with the other leftover segment, CB. See, here we're taking AC and comparing it to the leftover segment. Okay, so again, when we say C is 1/3 the distance from AB, they're saying this is 1/3 of the whole thing. Okay, now what this is saying is if you compare AC and if you compare AC and the leftover segment of your CB, okay, this ratio is 1 to 2. Okay, in other words, okay, if this is 1, this would be 2. Now, if you understand this, see, this segment is twice as big as this segment. That is true. In length, if this was like 5, this would be 10. If this was 12, this would be 24. Okay? Because it'd be twice as length. So kids find this confusing because 1/3 shouldn't that be like 1 to 3? No, you have to understand what you're comparing. When you say C is 1/3, means 1/3 of the whole distance. Whereas when you say ratio of AC to CB, you're comparing AC to the other small segments in the thing. So if this is 1, this is 2. Okay, if this is 10, this actually would be 20. Okay, if this is 15, this would be twice as much of that, would be 30, like this. Okay, so now, therefore, you should be able to convert these ratios of small segments into these ratios of comparing the small segment to the big segment. So here we're comparing the small segment to the big segment. Here we're comparing the two small segments to each other. Okay, so let me tell you what I mean. So let me give you this point, the point we had. Let's take this C out over here. Okay, now we said K was 5/6 the distance. Okay, remember we said K is 5/6 the distance from AB. So, and that ended up being somewhere over here. That was K. So what that means, 5/6 is this to this is 5/6. If you take ratio of the length of AK to AB is 5/6. So this means AK, the length of AK to AB is 5/6. Now watch this. This is different. But if I say the ratio of AK, let me use a different vibrant color, okay, the ratio of AK to KB, now that's different. We're comparing this segment to the smaller leftover segment, or whatever leftover. In this case, it's small. It could have been bigger, like in the first case, right? Now, what's the ratio now? So how do you take this understanding, the whole thing, and compare it to the ratio of the smaller parts? Well, that's easy enough. So if from here to here is 5/6, Okay, in other words, if you would divide the whole thing into 6 parts, this would be 5 parts. You know, right? If you have a cake and if you divide the cake into 6 parts and you took 5 parts, right? And you took 5 parts of that, how much is left? Well, 1/6 of the cake is left, right? Right? In the same way, if you hypothetically were to divide this whole segment into 6 parts and this is 5 parts, how many parts are left? 1 part is left. So the ratio of AK to KB is going to be 5:1. All right, so you have to understand what you're comparing in these ratios. Here you're comparing the two small segments that comprise or make up the big segment, whereas in the first case you're comparing the small segment to the whole big segment. Okay, now let me give you another question just to confirm our understanding here. I have a segment over here, let's call this point L and this is point M. And I have a point over here that's like point N. And I say the ratio from here is this. So the ratio of Ln to Nm is 3:4. Now, what this means is, I hope you understand, that Ln is 3/7. Very good. 3/7 of the whole thing. 3/7 of the whole thing. And Nm, okay, this segment is in fact 4/7 of the whole thing compared to each other. They're 3:4, but compared to the whole thing is 3/7 and 4/7. Okay, so I hope you understand, and you can convert these and problems regarding like 1/3 the distance and the ratio of this, ratio of that. I hope you can solve in this manner. Until the next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alamin. Assalamu alaikum.